Okay, over to you, Joe.
Thanks. Hello, everyone. My name is Joao, part of the TFA team, contribute to Hafnium mostly these days. I'm going to talk to you about the FFA v1.1 boot protocol implementation in Hafnium. So this is a feature that we've worked on recently. There's a few patches already uh, available for review in TF.org. Some of our design sessions have been questioned, so the point of doing this presentation is that hopefully everyone will get the full picture. We'll take the notes for future improvements if needed be, and all questions will be answered. So let's start with a very brief overview of the FFA v1.1 boot protocol. I won't get in too much detail of what the spec defines for this. I'm really just gonna give you enough information to fundament our design sessions and the following presentation. So in this version of the spec, the boot protocol has been updated. So there was an update on the structures to provide a means to pass information to the SPs. So well, most I should start by defining what the boot protocol is. So it basically is a means. Basically, the spec defines as a standard to pass information at boot time to the SP. And so in this version of the spec, the boot info the boot information structures have been updated, including the boot information header, which contains information about some metadata about the remaining boot information blob, including the number of boot information descriptors. The boot information descriptors are the boot information itself. It contains metadata about the data, contains then either a pointer to some region or a value itself. The various types, the spec defines a couple of types for the boot information, including FTT, which is going to be the focus for us in this work, which is provide a means to pass the SP's manifest to the SP. The spec defines that the boot information is what we see there in the picture. It defines it as the boot information blob, which is the aggregation of the header, the descriptors, and the data itself. There is a requirement for this regarding memory management, which is all the boot information blob should be passed to the SP in a contiguous memory segment. So in implementing this feature in Hafnium, the goals were to provide SPMC interoperability between the various versions of the SPMC, add the ability to pass the SP manifest to the SP, and then whilst pursuing these objectives, we tried to tackle a few other side, let's say, secondary goals, and one of them was to allow to package large SP manifest sizes into the secure partition package, which I'm going to talk a little bit further down the implementation, and allow to test SPs with different translation granules than 4K. So to tackle this implementation of the boot protocol, just going to give you a quick overview of what was decided and then getting to the details in the subsequent slides. So Hafnium supports one-to-one memory mapping between virtual addresses and physical addresses. And so we wanted to avoid having to copy the FFA manifest from its original position at load time. So in order to do so, we decided to include to allocate the space for the boot information blob as part of the secure partition package. So currently in Hafnium, we load SPs in this pretty much implementation defined package, which contains a header, the manifest, and the image of the SP. So in order to fulfill our goals, we needed to do some changes into the SP tool, which is and bump the version of the package to version 2, and change the way Hafnium processes the SP packages itself. For the subscription of a given type of boot information, we extended the SP's manifest. So for a given SP, we will need to add the information to its manifest that it requests a given type of information, in this case, the FFA manifest. I will show you later how this looks like. Just for the reference in the slides, if we were going to share them later, you can have a link to the boot protocol implementation. So having a closer look at the secure partition package first. On the left, you have version 1, which is the version that we were using up to this point. So with this version, the secure partition package header and the partition manifest were placed subsequently packed in the same memory region, let's say, in the same block. With this, Hafnium would just need to map the whole region as a read-only, parse the secure partition package header, and fetch the offset for the FFA manifest and process it, and then initialize the SP. With the new version, we're adding some space between the secure partition package header and the SP's manifest that's going to be reused for the purpose of the boot information blob to write the boot information header and boot information descriptors. So to do this, the changes that are available in the TFA code base target the SP tool, which is a tool that we use to effectively change this, generate these packages. So the tool has been now changed to receive the partition manifest offset and the images offset. And if no offsets are provided, it will for both of these, it will assume two default values, which is one 4K offset for the manifest and 16K for the image. The ability to provide these offsets to the tool allow us to provide offsets that are aligned with 60K or 16K or 64K translation granules for depending on well, if the SPs actually require it. It also provides a means to increase the space to place the FFA manifest. So essentially, these regions will be generated according to these manifests. So if we wanted to have more space for boot information in case that comes to be a necessity in the future, we just need to increase the the SP's manifest offset provided to the tool. Let's now have a look at how Hafnium processes this partition package at boot. So the first thing is it maps the first 4K of the whole secure partition packages and reads the secure partition package header. It checks for it checks for the version. It fetches the offsets and sizes for the image and the partitions manifest. So subsequently, it maps the whole region for the boot information as read-write and maps the FFA manifest region as read-only. It parses the manifest. If there is information requested, it will then write the header and the respective boot information descriptors into the first region. For a given SP, we also need to configure the field GP register num, which configures the register in which the SP expects to receive the address for the boot information blob. So, okay, so before booting the SP, Hafnium writes the boot information blob address to the specified register and maps the whole section from its stage 1 translation at EL2. Then initializes the SP. The SP mapping the whole secure partition package into the stage 2 translation of the SP. On the right, we see two logs. These are logs from the Hafnium CI. We have a couple of tests in place to validate this implementation. The first one is just validating the content of FFA boot information header and boot information descriptors. In this case, we're just passing the FFA manifest. And on the bottom log, we have a partition running and just reading, so fetching the offset for the for its manifest and parsing the FFA version just for the sake of trying and proving that it can access it. We also needed to change the way, made a couple of changes to integrate the changes made to the tool and to the change to the SP package format into the TFA build system. So in there, we had the SP make generator Python script, which was basically responsible for parsing a JSON file containing all the SPs to be deployed in a system with SPMC. So it would parse this file and generate all the artifacts and basically build everything for specific to the SPs to be included in the final FIP binary. So we have with this implementation, we have extended the JSON file for some SPs to contain the offset of both the image and the manifest. And we extended the referred script to include these offsets on the arguments to the calls to the SP tool. The script generates the spgen.make, which with its current version will generate these make rules that will be included in the main make file of TFA, and make sure the secure partition packages are generated accordingly. Just to give you a quick summary of the changes needed and the configuration needed for the FFA's SP's manifest. So in addition to configuring the GP register num that I mentioned before and specifying the boot info node listing FFA manifest, we would also need to change the entry point offset because of the changes made to, or at least care for the entry point offset because of the changes made to the way the secure partition package is being generated. Lastly, there's a few limitations that are worth mentioning. So this protocol only targets at SPMC to SPU boot information passing. This is completely parallel to the firmware handoff protocol. There are other boot information types that have been defined in the spec that we currently don't target yet, or we haven't tested and included in our implementation, which is a hop type and other implementation defined boot information types. The way we try to make an effort to make things as scalable as possible in these matters, but this is something that we still need to validate and implement further if needed be, and when needed be. And I would consider a limitation the fact that the secure partition package impacts the configuration of the entry point offset in the SP's manifest, and this could potentially be automated. This is something probably worth pursuing in the next couple of weeks.
A quick question, sorry, on the last slide.
Okay.
If that's okay. What's the firmware handoff protocol? Or what are you referring to as the firmware handoff protocol?
Do we have Olivier on the call?
Yeah, I can comment on this. So ARM recently defined another specification, so-called the firmware handoff protocol, which is mainly dedicated to passing boot data information from BL3.1 to BL3.3, so the normal bootloader. And if you open the FFA specification and you open the firmware handoff protocol, you will find quite many similarities in how the structures are defined, although that's really two different specifications, and each one targeting different goals. So to summarize, the FFA boot protocol is really related to passing boot information from a secure partition manager to secure partitions, and perhaps from the SPMD to the SPMC. And the handoff protocol really targets BL3.1 to BL3.3 boot stage. passing of boot information. So this specification can be found in the ARM developer portal.
Okay, yeah, thanks, Olivia.
Hi there. I had a couple of like general questions about Hafnium, and they might have overlap with what we're discussing now. So one of the things I want to ask is, what stage is Hafnium at right now? I'm trying to catch up with it as well a bit. So I looked at the Hafnium documentation, but that seems like the same it was before. So I don't know if that's up to date. But a couple of key things I want to check is, do you have intra-virtualization in Hafnium at the moment? And the other thing I want to ask is, do you plan to make Hafnium like so that it can be built in a way that you can exclude some things such as intra-virtualization or some other features. So if somebody wants to run Hafnium in a very cut down version, then it could be done in compile time. Is that part of the roadmap?
Can you hear me?
Now we can, yeah.
Yeah, we can hear now. Yeah.
Okay. So, I mean, I can answer to the best of my understanding. So other folks in the call from Hafnium project as well. So if I say something wrong, please stop me and correct me. About interrupt handling, we do support some level of virtual interrupts. Basically, I think there's handling of physical interrupts. Is Madhu on the call? I think he might be the best person to answer this.
I can help if you want. Or Madhu, if he's there, are you?
Yes.
I don't see him.
Yeah. Oh, okay. On interrupt handling, currently, so Hafnium integrates a gig driver at SCL2. So the intent is to handle secure interrupts while the secure runs or a secure partition runs, and or non-secure interrupts while a secure partition runs. And there are specific actions taken depending on whether this is a secure interrupt or a non-secure interrupt. Typically, a non-secure interrupt will be trapped by Hafnium and proceed with an operation called the manage exit, which will enter the secure partition again and then route to the normal world for handling of the non-secure interrupt.
Right.
And for secure interrupts, there is a support to actually trap the interrupt at SCL2 and then route the corresponding interrupt and resume the secure partition and vCPU which has registered to this secure interrupt.
Right.
Yeah, and to, if I may add, Olivier, I hope you don't mind. Yeah, there is gig virtual. It's not gig virtualization. It's more of the SPC para-virtualized interrupt interface.
Yes.
Right? If that answers your question even more directly.
Got it. Yeah.
And I don't believe you can compile out the interrupt code today, right? I think the way you wouldn't use it is by not registering for interrupts.
Got it. I think that's, okay, that helps because that's how it was at the big, like maybe a couple of years ago as well. So I heard there was some discussion about virtualizing interrupts. I guess that's further down the road, is that right? So this is kind of multiplexing interrupts, right? So interrupts first come to Hafnium and then Hafnium sends it to a particular.
I guess it depends on what you mean by virtualizing interrupts, right? We do have virtual interrupts supported today, right? Except that it's para-virtualized. If you mean gig virtualization, I think
Yeah, that's what,
I believe there is some plan, but I want to let Olivier and the ARM folks.
Okay, so yeah, to better answer the question, and thanks for highlighting this, Raghu. Yes, so the interface presented to the secure partition today is a para-virtualized interface. So we have a few number of Hafnium-specific HVC calls that can be done from the secure partition to the SPM to actually handle everything related to interrupt management. There is a long-term idea to actually adopt the geek architected virtual CPU interface, and which would eliminate the need for those para-virtualized interface. But it's, as of now, considered a lower priority, I would say, than better matching the very latest guidance from the FFA specification, like in the v1.1 EAC.
Understood. Yeah, without hijacking the whole question answer section, I just want to ask if there are any plans to kind of, I guess what we have right now is kind of minimum required for SEL2 SPMC, right? But if we extend functionality, are there any plans to kind of make it composable at build time? So if somebody wants to use a reduced version of Hafnium, not full-fledged, then they could do it.
Yeah, so that's an interesting question. So the query would be that any interrupt handling is removed. Is it what you're asking?
Sorry, I guess for interrupts, what we have right now, I think is kind of minimum required.
Mm-hmm.
So I don't think we need to compile that out. I don't think it would be a nice thing, but just going forward, are there any plans to have a way to kind of compile out some features in order to make it small?
I
guess more of a hypothetical question, but is there something that you're thinking about?
To be honest, not really, but it's always interesting to get such feedback. So it's not, the code base is not as modular as, for example, the Linux kernel can be with kconfigs and so on. There is some level of configurability because you can define a target platform and enable this or that option, but it's not at all modularized. So depending on what you want to remove or eliminate, it can be easy or very difficult. So it depends on the feature, eventually.
Yeah.
And in general, is there a reason you have the impression that it's large? Hafnium isn't that large, right? If you do see lines of code, I think it probably is around 10,000 or something lines of code inside the hypervisor, right? And even so, some of it is compiled out for the SPMC in particular.
Yeah, I think it is small. I'm just thinking like going forward, as we add more things, then it might actually, so it might be worth thinking about as we add things to have the option of not adding them in. So right now, the state it's in, I think it's okay. I think this is the minimum required, like I said before, but going forward, I guess that'll be a useful thing to consider.
Okay, if you already identify a list of things that you want to have removed in your specific build, then you can try to have a think to make it more modular.
Yeah, cool. I'm only starting to explore, so I'll come back if I find anything.
Okay, thanks.
Thank you.
I just thought of a question related to boot protocol, if that's okay. Joe, can you go back to your slide which showed the version 1 and version 2 of the boot protocol?
Yes.
Is there I forget, is there a max size that you defined for this allocated space and for FFA manifest? I know
if there is a maximum space.
Yes.
Not from the implementation of the boot protocol or the secure partition packaging tool or anything. I mean, not from the work that was done. There's no limit on what the value is. The only restrictions we have to the offsets and things is just to make it 4K aligned, which is the lowest translation grandeur for hafnium. In terms of size and offset, everything is possible besides that. Well, at least in theory.
Okay.
Well,
Yeah.
a maximum would be the maximum offset you can define with a 32-bit value, which is what is used on the offset of the secure partition package header.
Okay. And is there a so is the allocated space okay? There's no maximum on that either, right? Yeah, where you actually put the boot info descriptor, right?
Sorry, can you repeat the question, please?
So you have this box that says allocated space.
Mm-hmm.
Yeah, that can arbitrarily expand based on the partition manifest offset, right?
Yes.
Yeah, perhaps, Joao, correct me if I'm wrong, but we have some defined in the number of boot information descriptors, the maximum value. Something like 32 or.
Yeah. Yes.
But it's I think more than reasonable. I mean, today we only pass one boot information descriptor for the passing the FDTLS.
Okay.
But
so in theory, you can. I mean, if we think about information descriptors that just the size of its structure, you can reuse the whole allocated space just to, in theory, just to write boot information descriptor structures. But I'm not sure if you do that. I don't think I'm trying to remember if I've put there a hard-coded restriction, because we're just validating one use case. I don't think I've made any restriction there.
But I think the important I think the important part is that the offset for the FFA manifest and the offset for the image is kind of arbitrary. The FFA manifest can be placed far, and the image also very far in the final package binary. In a way, yes. There is no limitation on those offsets. That's, I think, what is important.
Right, and I can put the image before the FFA manifest, right? Then I don't feel like I saw any restrictions related to that as well. I can.
I'm not too sure.
No, that because that kind of aligns with the motivation to make this change, which was to have the boot information blob in a contiguous section. So in this picture, or maybe this one here, yeah, this one will do. So on the blue square, you write the boot information header and descriptors, and then you have the manifest. The manifest is supposedly the data that we're passing through the boot information protocol, and is part of the boot information blob. So if you swap the image and the manifest, you're kind of breaking this requirement that is defined by the spec.
I mean, yeah, in theory you could do. There's no requirement that your SP package header has to be contiguous with the boot information, right? So in theory, you could put that boot info blob after the image, and I'll tell you. Let me try and explain why, right? If you don't have a position independent executable, as you add more and more boot info descriptors, that could potentially extend, and then you would have to start changing your linker script as well to update your image to match where it is going, right? If you could put the image before the boot info blob, then if you have a statically linked and non-position independent executable, that can just remain the same, and your boot info can arbitrarily expand while still being contiguous.
Yeah, but that's probably a question to address to the architecture team, because as Joao mentioned, there is a strong requirement in the spec that the data associated with the boot information is contiguous to the boot information descriptors.
Correct. I'm not asking you to break that requirement, right? Just move what is marked as boot info blob after the image. Wouldn't that still meet the requirement, the strong requirement?
There's some okay. So I don't.
Oh, okay, I see.
We didn't contemplate that case. I think the changes we made to the tool would need to be revised. At the same time, I think at the beginning of the whole package, we would need to have the package header because it has information, the offset
Yes.
and the sizes to be reused. In such case, we would actually need to change our current format. It wouldn't be the same. We would need to bump the version again and create a different format for this. What you're saying is
Right. Yeah. So,
it may be feasible, but it's not what we have, if I understand correctly.
yeah, that's fine. And yes, yeah, I understand that. Just want to make sure, right? So I'm not saying we need to do that now. This is something I think it would be useful to consider, right? Given that we use one-to-one mapping in Hafnium, it's not like you can run the non-position independent image at some virtual address, but place it at an arbitrary physical address, right? So since we have that tight coupling, I think this could be a potential improvement where let's say the first 4K is assigned to your SP package header. So you could arbitrarily expand that. Your image would start immediately after that. So if it's non-position independent, you don't need to change anything. It remains the same. And then your boot info comes after that, so that it's arbitrarily extensible without having to move the image.
Okay.
Yeah. So yeah, something to think about, right? If there's no need right now, I think, but
yeah. So the idea, I think that popped up in my mind at some point, but
okay.
I proposed differently because I was trying not to waste the first section in the system. So that's such that basically after reading the secure partition package header, we're just basically like saving a copy locally and just reusing the whole segment for the boot information header and descriptors.
Yeah, understood.
But I understand what you're asking as well. I guess it's something worth having in mind for future improvements if that comes to be a need.
Yeah, okay. Makes sense.
At the same time,
I think where this is coming from. Sorry, go ahead.
I was just going to say that we did mention this configuration of the entry point offset to be configurable as a limitation. It could probably be automated. That probably wouldn't resolve all the issues that you described with the new format, but it probably ease the life of the system integrator.
Actually, yeah. So that's why this thought popped up into my head, right? If we automate the entry point offset, it won't work for a non-position independent executable, right? If your image has to run at hex 8000 address, and your manifest size increases, and I automatically update the entry point offset, yeah, the SP could break, right?
Yes.
If it's yeah. So we have to think through this again, I guess, for a non-position independent executable.
Okay. Yeah, just something to have in mind. Thank you for that feedback.
Yeah, no problem. Thanks.
Okay. Are there any other questions?
Okay, so if there is no question on the presentation, anyone has any other questions or topics to discuss? Okay.
Hi there. Sorry. I posted a question on the mailing list regarding long-term support. I know there was a discussion before, but I was part of that. Are there any plans for TFA to support long-term support?
So Olivier, Sobi, anyone want to take that?
I can only say that it's being discussed, but
Yeah.
nothing will be decided on this front. Yeah. From what I understand, yeah, this is considered discussed. It's likely that this would go through partner engagement as well, beyond just ARM, I think. But that's the only feedback I have. Sandrine, sorry, I interrupted you.
No, I did. Sorry. No, I was going to say about the same thing as you. Our position is that we just don't have the bandwidth to do that on our own. I mean, ARM doesn't have the bandwidth to do on their own. So yeah, it would be a joint effort with some other companies for sure. So I guess it depends on you know, which company would be willing to help, and what kind of, I guess we need to define also what kind of long-term support exactly we are looking at, depending on interest.
Right. So the problem with a partner doing it is that we need somebody to say that this is the long-term support release, and then kind of define, and who makes that call. If partner makes that call, isn't that, how do you define? So I guess we need somebody, either we need consensus, which I think might be a bit too slow, or somebody who's in a leadership position to say this is the long-term release, and then support just with security patches for a certain number of years.
Yeah, I'm to be honest, I'm not sure how to go about it. I guess really this isn't an ask from ARM. So I guess there should be some initial proposal from one of the companies who would be interested in seeing LTS being maintained, and then this can be discussed further on the mailing list. That's one option.
Yeah, I believe Varun had a presentation a year or two ago about LTS support. Yeah, looks like we never followed up on it. Might be worth revisiting it. I guess it also depends on defining what long-term support means, and you know, who is going to guarantee quality of it, who's going to guarantee that the security fixes work on it and backport it and things like that, right?
Right. Yeah. I guess. I mean, we can start the discussion by saying like these many years. I'm not saying we should do it right now, but some basic definition of long-term support, like these, how many years, and then we can say what sort of patches. And I guess let's say we start with security patches in 3 years, just as an example. But then the question ultimately comes down to who makes the call, and a partner making the call. I don't think, because partner would be interested in their own immediate interests, not for the community. And that's where the question comes in. So that's why I think some partner driving it may be unfair. We can come up with, like, some partner can come up with a suggestion, but a particular partner driving it will be unfair, I think.
Yeah, I don't think the intent was for a partner to drive it. I think it also requires partner bandwidth. And you know, Sandrine, correct me if that was not what you said.
No, that's what I meant.
We need help from need help from partners, not that partner makes decisions, or you know, by themselves.
Yeah, exactly. Yeah, it would be, as I said, a joint effort, maybe led by the trustedfirmware.org, you know, what's the word? I mean, group. But I guess, yeah, I can imagine, Okash, that, you know, many different partners will have different definition of LTS and different requirements. But I think, you know, if every partner who is interested in some form of LTS could answer to your to the email thread to specify their expectations, then maybe from that data, then we can maybe find a pattern and agree on what would fit the I mean most partners. Because if we're just waiting for someone to take the lead on that, then it might never happen.
Hello, I'm coming with a very different question, which also has to do with the Hafnium long-term perspective. I'm listening in, especially with my interest in CCA and RME support. And I was just wondering, we were discussing Hafnium currently with the perspective from trust zone, like 2 security states. What are the intentions and foreseen usage of Hafnium in the context of there is a realm secure state and a non-secure world that's operating? Can I hear your voice on that?
I can try. So we have an parallel track in making sure that the SPM design, well, implemented by Hafnium, still works in context of enabling 4 walls on an RME enabled system. Eventually, there are no major changes or design changes to do to Hafnium to make it work in a 4-wall model. Just a few feature additions and some support added to the FFA specification, but actually that's completely orthogonal to ARM CCA in the way that the FFA specification just works in context of ARM CCA independently from any other enablement happening specifically for ARM CCA. Does that answer the question?
Yes, in a way, yes, it does. So it's really like it will be focused on this world and running in the secure world. I was wondering, because while I was looking at ARM CCA, I especially looked also into the generic interrupt controller. And when you were talking about having a special module for virtualized interrupts in the exception level 3, I was just wondering how that might interfere with how it's currently defined for RAM interrupts.
Actually, perhaps I did a mistake, but the gig driver we were mentioning is specifically running at SCL2.
Okay.
And
then it's okay.
Yeah, so in the long term, we can even imagine that perhaps there is less support around the geek within EL3 or minimal support, and that anything related to interrupts in the secure world should happen at SCL2. That's a model. I'm not yet too sure if that's how it will happen, but yeah, secure interrupts would really be handled only in the secure world, starting with SCL2. I mean, in context of ARM CCA.
Okay, thank you.
So any other questions? All right. So thanks everyone for joining. So we'll call it done.
Thank you.
Thanks all. Bye.
Yep.